Okay, so now let's do the same thing for this one. So vertical asymptotes, since there's nothing to cancel, I can see where the denominator equals 0 is where there's a vertical asymptote. So that's at x equal negative 5 over 6. That was done. All right, so now let's find the horizontal asymptotes by taking the limit as x goes to infinity and then towards negative infinity. So from the numerator, I get this, denominator this. So then limit as x goes to infinity, I'd get root 2 absolute value of x over 6x. And since I'm going to positive infinity, using the absolute value of the definition of the absolute value, I get root 2 times just a positive x. So these x's cancel, and so I get root 2 over 6. So if I do the same thing going towards negative infinity, root 2x squared over 6x, limit as x goes to negative infinity. Important step to show that you're getting this. And then you're going to use the absolute value definition. And since I'm putting in negative numbers, the way I make it positive is I take the opposite of it. So now the x's cancel, so I get negative root 2 over 6. So the horizontal asymptotes are y equal plus or minus root 2 over 6. Okay, let's just do one more here. So vertical, oh, I see there could be factoring. So before I just go setting the denominator equal to 0, I'd better factor this. So I see difference of squares in the numerator. And then this factors to x plus 1, x plus 2. So these x plus 1's cancel. So this is the most simplified. X plus 2. Okay, of the function. So the vertical asymptote will be where the denominator equals 0. So that's negative 2. So now if I'm going to take the limit as x goes to infinity of this, I see taking highest powers, I get x over x. Oops, forgot the infinity. Those cancel, so I just get 1. And then I can see the same thing will happen if I'm taking the limit as x goes to negative infinity. I'll get x over x, so it's 1. So there's only one horizontal asymptote, and that's y equal 1. Okay, so this graph of arctangent of x we will be using until we end even Math 151. So this is the graph, goes through the origin, whoops, goes up like this. So it has a horizontal asymptote at pi over 2 and a horizontal asymptote at negative pi over 2. And that's what this is saying. As you're going marching out to infinity, the y values are going up to pi over 2. As you're going back to negative infinity, the y values are going down to negative pi over 2. Okay, so let's play with things because we're not just going to get straight that always. So if I have this in the angle, you want to go inside first. So if I take 3 times infinity, that's like saying infinity. Arctangent of infinity is pi over 2. Okay, what about this one? Go inside first. So 3 over infinity, that's a 0. Oh, I'm looking at finding arctangent of 0. Arctangent of 0 is 0. Here I'm going inside first. Pi times infinity is infinity. Sine of infinity, dne. Okay. Oh, is this the same thing? 2 times infinity, infinity. Cosine of infinity, same thing. So be careful. Don't just come to the conclusion that it's in dne if it's sine. So this one here, if I go inside first and put in the infinity, I get pi over infinity. That's 0. Sine of 0, that's 1. Okay, how about this one? Negative infinity put inside. 4 times negative infinity. And so again, let me just draw the graph. As I'm going to negative infinity on this graph, I get negative pi over 2. Okay, let's do this again. So negative infinity divided by 4 is negative infinity. And then arctangent of negative infinity, again, it's negative pi over 2. So you remember that e to the infinity is infinity, right? Okay, so here I'm going to put the infinity in first. Infinity, arctangent of infinity, that's pi over 2. Here we go with another one. So I have e to the infinity. Always go inside the angle first. So e to the infinity is infinity. 3 over infinity is 0. So this is like saying find arctangent of 0. That's 0. All right, so then if we go to the next one, plugging in infinity into the e, that's e to the infinity. That's infinity, sine of infinity, dne. About this one, put in, it's got negative exponents. I'm going to suggest when you see negative exponents that you put them in the denominator, because then you can see what's happening. So now when I put in infinity, I get e to the 2 infinity. So this e to the infinity in the denominator, that's 1 over infinity. With that 1 over infinity gives me a 0. This one here, think about it. This negative infinity and that negative 3 would make a positive. So I would end up getting e to the infinity. That's infinity. Think about this one. Put the negative infinity in. That negative infinity would make it 1 over e to the 3 times infinity. That's 1 over infinity. And so that right in there, because of the negative infinity, would be 0. So then I'm finding arctangent of 0, which is 0. All right, let's do this one. Put the negative infinity in. So you're looking at e to the negative infinity. Again, think of it like this. So that's 1 over infinity. And so then there's that 4 carrying along. So that's 1 over 4 times 0. So all of that is 0. And so I end up getting arctangent of 0, which is 0.